Now that you know a lot about systems and you reviewed how to solve them using different approaches, as well as how to build systems from contextual examples, what happens if your system has three variables? How do we solve that? And how do you check to see that your solutions are correct? Let's look at a first example. Go ahead and pause the video and you give this a try. How could you solve this system? Think about what you know and try to solve it. One way to solve this is to look at this top equation and see that we have variables that have no coefficients. It might be easy to isolate one of these on one side of the equation and use a substitution method. So let's start with that. If I move y to the other side, this equation then becomes x equals y plus 6. Now I know what x is, and that's something that I could perhaps substitute into my second equation here for x. Let's try that. Now I've substituted this in for x, we just need to distribute and simplify this equation a little bit. So we would get 2y plus 12 minus 3z equals 16. We still have two variables, so there's not a lot we can do yet. But let's look at our bottom equation. Here we have a z that's isolated as well. And in here I have a z. If I can isolate this z, perhaps I can get this equation to just have one variable y. So let's go ahead and move the 2y over and isolate z. And here we go. I subtracted 2y to the other side, so now I've isolated z, and I can take what z equals and perhaps plug it in here for this z. So let's go ahead and do that. I can see that now that I've substituted this in here, I only have y's. So I'll be able to simplify this equation and determine my y. Let's go ahead and distribute the negative 3 in through the parentheses. Combine our like terms. 12 minus 12 is going to go away, and I will get 8y equals 16. And now I know that y is equal to 2. So I have one of my answers. If I look through my equations, I know that y is 2. I'm going to be able to solve for z here and x in the first one. In this first equation, I substituted 2 for y, and now when I solve, I know that x is going to be equal to 8. In this bottom equation, I can also substitute a 2 for y and solve to determine what z is. So 4 plus z equals 4. When I subtract 4, I get 0. I have these three solutions, but how do I know that they are correct? To determine if they're correct, I need to perform a check. A check is as simple as just taking my three solutions, plugging them in, and making sure that they are true in each of my equations. Let's give it a try. In the first one, we would have 8 for x minus 2, and that should equal 6. Well, 8 minus 2 is 6, and 6 does in fact equal 6. Works there. Let's go ahead and try the second one. So we would have 2 times 8 minus 3 times 0, and that should equal 16. Well, 3 times 0 goes away, and we're left with 16, which does in fact equal 16. So in two of these, we know we have the right answers, but we need to check all three. So let's do the last one. We would have 2 times 2 for y plus 0, and that should equal 4. Well, 2 times 2 does in fact equal 4, and 4 does equal 4. Now I have checked all my work, and I know this is correct. Let's try one more example. Once again, pause the video, try to solve this system on your own, and then come back and we'll solve it together. To solve this system, we can use a similar approach that we used last time. We can look at our first equation and our last equation and see that we have variables that have no coefficients. So it might be easiest just to isolate some of these variables. In the first one, let's isolate y. When I did that, this is what I got. Now what I'm going to do with that then is substitute this in for y into my second equation. Now that I've substituted, all I have to do is distribute the negative 3 and then simplify. If I do all that and simplify, this simplifies down to 10x plus 7z equals 19. Now I don't have this equation solved for x or for z, but I'm down to two variables. So let's think about what I could do next. I could look at this bottom equation and I could isolate y. Now that I have isolated y, I can take this and plug it in for y somewhere. I think I'll go ahead and plug it into my top equation because it looks a little bit simpler. So I'm going to have 2x plus, and then I'll have all this. Now that I've plugged this in, all I have to do is simplify by combining my like terms. When I combine my like terms, I'll be left with this equation here, 8x plus 3z equals 10. Notice that this equation and this equation up here both only have x and z variables. So what I can do is I can use regular elimination with these equations. I have 10x plus 7z equals 19, and in this one I have 8x plus 3z equals 19. I can decide if I want to eliminate my x's or my z's, and I'll do that through elimination, since none of these variables are isolated or don't have a coefficient. So maybe for this first equation, I'll multiply this by a -3 in order to turn the 7 into a -21. And in my second equation, I'll multiply this by a 7, a +7, to turn this into a +21. At this point, I just need to add my equations together, and I'm left with 26x equals 13, since these z's will eliminate. So now I know that x is going to be 13 over 26, or 1/2. At this point, it'll be easy for me to find the other variables. I'll use one of these equations to find z next. So perhaps I'll use 10x plus 7z equals 19. In order to do that, I'll take 10 and I'll plug in the 1/2 that we just found for x, plus 7z equals 19. Well, 10 times 1/2 is 5. And then if I subtract 5 from 19, I get 14. So then it determined that z would be 2. So now I know that z is 2, that x is 1/2, and I can use any equation to find y. So in order to find y, let's take this top equation. Oh, actually, let's take the equation here where y is already solved. Y is equal to 6 times x. So let's go there. Y is equal to, well, 6 times 1/2 is going to be 3, plus 2 times z, so z is 2, so that's 4, minus 2. 7 minus 2 is 5, and now I know what y is. But again, just like before, we should always check our answers. So we should take 2 times 1/2, which is 1, plus 5, which is 6, plus 2, which is 8, does in fact equal 8. So the first equation checks when I do my check. On the second equation, 4 times 1/2 is 2, minus 15, which is going to give me -13, plus 8 will give me -5. So that one checks out. And I'm doing these in my head. You should double check these on a piece of paper. Now let's do the last one. -6 times 1/2 is going to be -3, plus 5 is 2, minus 4 is a -2. So all three check out, and I have indeed found the solutions to a system in 3 variables. So now you know what to do if a system has 3 variables. Isolate a variable and then use substitution. How do you check your solutions? You take your 3 answers and you plug them back in and make sure that each of those functions is true for all of your answers.